Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question. Question number 22 of NEET physics paper of the year 2014. Students, let us solve the next question, which is number 22. A speeding motorcyclist sees traffic jam ahead of him. He slows down to 36 km per hour. So there is a person in a motorbike and is moving with a velocity of 36 km per hour. He slows down to this, so this is moving with this one, and he finds that traffic has eased and a car moving ahead of him. So there is a car here which is moving with 18 km per hour, which is ahead of him. So is honking at a frequency of 1392 Hz. So is blowing horn the frequency of the actual frequency of this horn, frequency of the source of sound is 1392 Hz. If the speed of sound is 343, speed of sound is 343 meter per second. The frequency of the honk as heard by him will be. So heard by him means this person. What is the frequency heard by this person? Suppose this is n prime. That you have to find. What is the frequency heard? Now, if you think that in this road, this is moving with 18 km per hour, which is 18 into 5 over 18, which is 5 meter per second. This is how you convert kilometer per hour to meter per second, by multiplying 5 over 18. Here also, if I multiply 5 over 18, it becomes 18 to the 36, so 5 to the 10, so it is 10 meter per second. So this one is moving with 10 meter per second, and this is moving with 5 meter per second in the same direction. This is the observer with 10, and the source is also moving in the same direction with 5. Okay, now what is the frequency heard by this? If the frequency blown here is n, the formula is that the frequency n prime equals to the actual frequency, the speed of sound, plus minus the speed of the observer. But as the observer is approaching the source, so frequency will increase, so this will become plus, divided by the speed of sound plus minus velocity of source. But the source is moving away from the observer, so that means frequency is decreasing. If this frequency has to decrease, this has to be positive, so plus of the source. So this is the formula that we are going to use it here to get the answer. So let us put these values. N prime is n v plus v naught divided by v plus vs. N is 1392 given in the question, original frequency. The speed of sound is 343 given in the question, plus v naught, observer is moving with a speed of 36 km per hour, that is 10 meter per second, divided by 343 plus 5 for the source. Now traffic is now 18 km per hour for the car. Okay, now if I solve this, I'll get the answer 1392 into this is 353 divided by this is 348, and the answers are also in whole numbers. So just we have to simplify that. If I want to actually go for the calculation, let us solve that. If I cut by some multiple of this, I think this number is given. You should also think that if this number is given, then it should be some multiple of this, because why otherwise this number is given 1392 frequency. So to simplify that, to make the calculation easier, they always gives us numbers. Otherwise there is no need for giving 1392 as the frequency of the honk sound. So therefore you must first try to multiply this with try the hit and trial method. Multiply 2 is there, so it should not be 2, it should not be 3, it should be 4, at least 4, because 4 8 is 32, 2 will come. This way you can solve. Otherwise if you go for simple calculation, divide by 4, divide by 2, then it will take long time. So I do this way, 348 multiply by 4. I choose 4 because this 2 is there. So 4 8 is 32, 2, 3 carries 16, 19, 16 plus the 19, 1 carry, 4 3 is 12, 1 is 13, so 1392. That is there. So if you cut this, you will get 4 here. So 4 into 353. So that is 353 and 4 multiply. 4th is 12, 1 carry, 20, 1, 2 carry, 4th is 12 and 14. 14 1 2. 1 for 1 2, this comes out to be 1 for 1 2 hertz. If I see the options, then 1 for 1 2 is option number 3. Okay, so that is the correct answer to this question. So basically the idea is that you have to use this formula. Generally in textbooks they always give this plus this minus, or this minus this plus, but it is not necessary that this is one of them is positive then other should be negative. Both can be positive and both can also be negative. Both can be negative if you change the reverse the directions of the source and observer. Now in this case the observer is following the source. If I reverse the direction, then when the source is following the observer, then in that situation both will be negative. Okay, so that formula is generally not given, so therefore I think this is the question that is asked to check. Okay, so for this question this is the answer. Thank you.